Srinivas working as an assistant professor in IARE college. Okay. Today we'll discuss about normalization. Okay. It is a very important concept in databases. Normalization is an important database concept that is used to maintain data in a good state. Okay. Let us see about normalization. Let us see what is normalization. Normalization is nothing but a database design technique that reduces data. Start 1, 2, 3. Good morning, I am Srinivas Gowda, working as an assistant professor in IARE college. Today we'll discuss about normalization. Normalization is a important database concept used to maintain data in a good shape. Okay. Getting started to normalization. What is normalization? Normalization is a database design technique that reduces data redundancy and eliminates undesirable characteristics like insertion, update, and deletion anomalies. Normalization rules divides larger tables into smaller tables and links them using relationships. The purpose of normalization in SQL is to eliminate redundant or repeated data and ensure that data is stored logically. So we will break the entire data into multiple tables and we'll join them with various joins. Okay. So this will maintain the data in a good manner. Okay. The inventor of the relational data model, Edgar Core, proposed the theory of normalization with the introduction of first normal form, and he continued to extend theory with the second and third normal forms. Later, he joined with Raymond F. Boyce to develop the theory of Boyce-Codd normal form. Okay, we have about 6 forms of database normalization forms. Here is a list: the first normal form, second normal form, third normal form, the fourth or the Codd normal form, the fifth, and the sixth forms of the database forms. Now let us see each one of them. The theory of data normalization is still developed further. For example, there are discussion even on the 6th normal form. However, in the most practical application, the normalization achieved is best in the third normal form. So when you have normalized your database up to third, you are in good shape. Okay. The evaluation of normalization theory is listed above. First normal form, followed by second, third, and Boyce and Codd normal form, fourth, fifth, sixth. If you are able to achieve up to 3, you are in good shape. Okay. If you need to apply the second normal form, first you have to prior to apply the first normal form. Like this going forward. The data now we'll see an example of the database normalization example. The database normalization form can easily be understood with the help of case study. Assume a video library maintains a database of movies rented out. There is a video library which gives movies on rent. Without any normalization form, all the information is stored one table, like movie name. The customer name is customer name, the physical address, the movie rented, and how he is called as. It is Madam or Mr. Okay. So if you don't apply normalization, the entire data is present in one table. Example: Robert Phil was taken one movie. Okay. The Forgetting Sarahs, and the Jones has taken one movie, Pirates of 2 movies, the Pirates of Caribbean and the Clash of Titans. Whereas Robert Phil, who is one more Robert Phil, not the earlier one, who stays in 5th Avenue, has taken one Clash of Titans movie. Okay, this is the basic database how table it requires. Now we'll apply normalization to this. Okay, here you see the you see the movies rented column has multiple values. Now let us move into the first normal form. The first normal form, the rules is that each table cell should contain a single value. Each record should be unique. Okay. The first normal form says that every table cell should have one single value. You cannot have multiple values in one single column, and the record should be unique. So for that, we will break the movies rented into multiple columns. As Jones has taken 2 movies, we'll have 2 additional records for Jones for each movie. So one movie is the Pirates of Caribbean, another is Clash of Titans. Here we are having 2 records for Jones. So if we have applied the first rule is that each table should contain one single well, followed by each record should be unique. Now the entire record is unique. There is no duplicate record in the as earlier. Okay, this is the first normal form. Okay, understood? Now we'll see, before going to the second, we'll have to see few concepts in SQL Server. What is a key? A key is a value used to identify a record in the table uniquely. A key could be a single column or combination of multiple columns. Note, the columns in a table that are not used to identify a record uniquely are called non-key. Say a unique key is a record which unique key in a table is singly identifies the entire row. Whereas if you're not able to distinguish uniquely, it is called non-key columns. Now, what is a primary key? A primary key is a single column used to identify the database record uniquely. It has the following attributes. The primary key cannot be null. The primary key must be unique. The primary key values should rarely be changed. The primary key should be given a value when a new record is inserted. Okay. Now we have seen primary key. Now we'll see what is a composite key. A composite key is a primary key comprised of multiple columns used to identify a record uniquely. In our database, we have two people with the same name, Robert Phil. They live in different places. We'll see an example, Robert Phil, who stays, there are two Robert Phils. One stays in 3rd Street, 34, other in 5th Avenue. So here, the names are common, hence you need to name as address to uniquely identify records. So the combination of name plus address will be a composite key. Hence, we require both full name and address to identify record uniquely, that is composite key. Now we'll apply the second normal form. In that, first it should satisfy the first normal form. What is first normal form? The record should be unique and there should be one record per row. Okay, one value for record. Okay. Now to apply the second normal form, first it should satisfy the first normal form, and rule 2 is single column primary key. It is clear that we cannot move forward to make our simple database into second unless we partition the table. So we need to break the entire database table into two tables. One table will have the total movies in the library. The second, how they can be linked with who has taken the movies for rent. For example, if you see here, we have two tables here. One for the movies rented, one for the movies rented from our library. The second, the person who has taken his library here. Okay. Now we have divided our first normal table into two tables called table 1, table 2. Table 1 contains the member information and table 2 contains the movies rented. We have introduced a new column called membership ID, which is the primary key for the table 1. So this membership ID is the primary key for this table 1. The records can be uniquely identified in table 1 using the membership ID. So when you see what is the membership, if you see here, the 3 means membership of Robert Phil has taken 2 movies. One movie, that is Clash of Titans. Whereas Robert Phil, who stays in 3rd Avenue, has taken 2 movies. One is The Forgetting Sarah Marcel and Dad's Little Girls. By this, we are able to one table is break into 2 different tables. Okay. Now, in table 2, membership ID is a foreign key. A foreign key references the primary key of another table. It helps to connect your tables. A foreign key can have a different name from the primary key. It ensures rows in one table have corresponding rows in other. Unlike the primary key, they don't have to be unique. More often, they are not. The foreign keys can be null even though primary key cannot be null. So here, our main table is the numbers. First we have 2 tables here. Okay. The foreign key references the primary key. Foreign key can have values present in the primary key. It can have other name that of the primary key value. Okay, primary key value. Here, my customer data is stored in table 1, like 1, 2, 3, having there are 3 members, and we are linking this membership ID to the second table, which is the movies which we have in our library. So if you see Jones has taken two movies, The Pirates of Caribbean and Clash of Titans, whereas Robert Phil, who stays in the 34th Street Avenue, has taken two movies once again. Okay, by this, we are able to have able to join two tables using the foreign key and the primary key concept. Okay. Now, why do we need a foreign key? Suppose a novice means who is not well versed with the database. Now, suppose a novice inserts a record in a table B, such as insert a record in table 2 where membership ID is equal to 101. But there is no membership ID in the table 1. Or table 1 consists of only 1, 2, 3. If you try to insert in 101 to the child table, you will get an error. That error is called as referential integrity error. You will be able to only insert values into your foreign key that exists in the unique key in the parent table. This helps in referential integrity. The above problem can be overcome by declaring membership ID from the table 2 as a foreign key of membership of the table 1. So the table 1 membership is the primary key. We are having that key as a foreign key in the second table. So if you try to insert a invalid ID which is not there in the membership ID, you will get an error called as referential integrity error. Now, if somebody tries to insert a value in the membership field that does not exist in the table, the error will be shown. What are transitive functional dependencies? A transitive functional dependency is one when changing a non-key column might cause any one of the other key non-columns to change. Consider table below. Changing the non-key column full name may change the solution. Here Robert Phil is Mr. Suppose you have changed that name to Miss Nancy. Here the solution will be a problem because it is here master. Actually, she is Miss. Now, so for that we'll have to go to the third normal form. The third normal form says that it should satisfy the first and second. It should satisfy the first and two normal forms, and also it should have no transactional functional dependencies. Now to move our second normal form into third normal form, we again need to divide an odd table. So we'll have one more table called for solution having Mr., Mrs. and Mrs. Doctor. Now this is one more primary key table. Now we will have this primary key value as a foreign key in our table 1. So table 1 now here Robert Phil is Mr. Suppose if we change that Robert Phil to Miss Nanny, now we can have it as number 2. Okay, we have again divided our database table and create a new table which stores the solution. In there are no transactive functional dependencies. Hence, our table is in third normal form. In table 3, the solution ID is a primary key, and in table 1, solution ID is a foreign key to the primary key in the table. Now, with our little example, is at level that cannot be further decomposed into attain higher level of forms of normalization. In fact, it is already in higher normalized forms. Separate efforts for improving into next level of normalization are normally needed in complex databases. In our case, we have achieved the entire thing in this third normal form, as we have removed the functional transitive dependencies. Now let us continue to other form of normalization. Boys, even when the database is third normal form, still there could be some anomalies resulted if it has more than one candidate key. So sometimes is BCNF is also referred as 3.5 normal form. Next, the fourth normal form. If no database table instance contains two or more independent and multi-valued data describing the relevant entity, then it is the fourth normal form. Fifth normal form is only if it is the fourth normal form, and it cannot be decomposed into any other small table with a loss of data. Next, we have the sixth. It is still being proposed. It is not yet standardized. However, it is being discussed by database experts for some time. Hopefully, we could have a clear and standardized definition for sixth normal in the near future. Summary. we'll see a summary. The database designing is critical to successful implementation of the database management system that meets the data requirement of an enterprise system. The normalization DBMS helps produce data systems that are cost effective and have better security models. Functional dependencies are very important component that normalize the database process. Most database systems are normalized up to third normal form. A primary key uniquely identifies the record in a database table and cannot be null. The foreign key helps to connect table and represent the primary key. Now the advantage, we'll see the advantage. We'll see of advantage of normalization. The normalization is a process of organizing data to avoid duplication and redundancy. Some of the advantages are better database organization, more tables with small rows, more tables with small rows. As we have seen, that one entire table is break into 3 tables. So more tables with small rows, efficient data access, greater flexibility for queries, quickly find information, easy to implement security, allows easy modification, and also the reduction of redundant and duplicate data, more complex database, ensure consistent data for modification. Now, what do we mean? See, till now we have seen what is normalization. Now there is something called as denormalization, which is exact opposite to the normalization. Denormalization refers to a technique which is used to access data from higher to lower forms of data. It helps the database manager to increase the performance of the entire infrastructure as it reduces redundancy into one table. It adds the redundant data into a table by incorporating database queries and the combined data from various tables in a single table. The first table is a denormalized table. You have entire information in one table. This is denormalization.
Like, share and subscribe. Hit the bell icon for more updates.